Name the following compound, NaNO3. First, I need to figure out who Na is. When I find Na on the periodic table, I'm going to see that it is sodium. It is in the first two columns, which makes that a representative metal. So that means that I do not need an oxidative state, and I can just go ahead and name the metal. And then I can proceed. NO3, that's multiple atoms, so that means that is going to be a polyatomic. So I'm going to find NO3 on the inside of my periodic table. I'm going to see that that has the polyatomic name of nitrate. I do not need to change any suffix about it, so I am done. NaNO3 is sodium nitrate. Name the following compound, MnPO4. First, I need to identify who Mn is. Mn is manganese, and manganese is within that transition metal block. It's not part of Katzenagel, so that means I do, in fact, need oxidative states. And I will remind myself of this by giving myself a set of parentheses. PO4 is multiple atoms, which means that that is a polyatomic ion, so I'm going to find PO4 on the inside of my periodic table, and I'm going to see that its name is phosphate. I do not need to change anything about phosphate's name since it's a polyatomic. I need to figure out what the oxidative state is now, so I'm going to go ahead and do my anion versus cation math. My anion is phosphate. My subscript for phosphate is going to come by how many phosphates I have. Phosphate is definitionally PO4. I do not have any parentheses, which means I don't have a multiplier, so I only have one phosphate. Phosphate definitionally is going to have a charge of -3. 1 times -3 is -3. Equal and opposite of -3 is +3. I only have one manganese, so 1 times what is 3? 1 times 3 is 3. Arabic to Roman. Manganese 3-phosphate is the name of that compound. Name the following compound, AgClO3. Ag is going to be silver. Silver is in that transition metal block, however, it's part of our exceptions, which is Katzenagel, which means that everybody is expected to memorize what the charge is for silver, so I get to treat it as a representative metal and not calculate the oxidative state. ClO3 is multiple atoms, which means that's a polyatomic ion, so I need to go ahead and find that on the inside of my table. ClO3 is going to be chlorate, so the name of this compound is just going to be silver chlorate, since polyatomics don't need to change their name once they're in a compound. Identify the cation and anion in the following compound, KMnO4. So this is a little bit tricky because we have more than 2 elements here. But I know that I can always check to see if anything is a polyatomic. So I know that it's going to have O and Mn, and let's see if that is in fact a polyatomic. MnO4 is in fact a polyatomic. It is permanganate. It is in second position, which would make that a anion. And my cation is whoever is going to be in that first position, so that is potassium, K. What is the anion's name for the compound MgSO3? So I need to identify who is my cation and who is my anion. The person in the first position is manganese, so that's going to be my cation. So my second position is going to be SO3. That's a polyatomic, so I can just go ahead and look on the inside of my periodic table to find it. SO3 is going to be sulfite. What is the correct formula for nickel 3 chlorate? First, I need to identify who nickel is. So nickel is going to be element symbol Ni. Nickel 3 is going to mean that nickel has a charge of +3. Chlorate, the suffix -ate, gives me a hint that that is in fact a polyatomic ion. So I need to figure out who chlorate is. I find it on the inside of my periodic table under the polyatomic ion list. Chlorate has the formula ClO3 with a charge of -1. I will then crisscross charges for subscripts. And when I do so, I'm going to notice I'm going to have multiple chlorates, which means that I need to protect chlorate within parentheses. I do not need multiple nickels. So my formula for nickel 3 chlorate is going to be NiClO3 3. What is the correct formula for rubidium hypochlorite? Rubidium is going to be element symbol Rb. Rubidium is in the first two columns, which would make that a representative metal, which is why I do not have an oxidative state here. Rubidium is in the first column, which means it has one valence electron. So I have one. I'm going to give that away. So rubidium with a charge of +1. Hypochlorite, suffix -ite, gives me a hint that that is a polyatomic ion. So I'm going to go ahead and find hypochlorite on my polyatomic ion list. When I find it, I see that it has the element formula of ClO with a charge of -1. I'm going to crisscross charges for subscripts. Since I do not have multiple hypochlorites, I do not need parentheses, so I can just leave it as RbClO. What is the subscript for the anion in the correct formula for silver nitrate? So first I need to figure out who silver is. Silver has the element symbol Ag. It is in that transition metal block, but it's part of our exceptions list, which is Cadz and Nagel, which means I'm expected to memorize the oxidative state for silver, which is why I do not have it stated in the name. Silver's memorized oxidative state is +1. And then nitrate is going to be a polyatomic ion. Nitrate has the formula NO3 with a charge of -1. I'm then going to crisscross charges for subscripts. I do not need multiple nitrates, so I do not need parentheses. And so I'm going to just leave it as AgNO3. I've specifically asked for the subscript on the anion. This is me asking how many of that anion, the nitrate, do I have. I didn't have to multiply anything, so that means that I only have one nitrate. What is the subscript for the cation in the correct formula for ammonium carbonate? Ammonium is our one and only positive polyatomic ion. It is found inside of the periodic table, and its formula is NH4 with a charge of +1. And carbonate is a polyatomic ion as well. It has the formula CO3 with a charge of -2. When I crisscross charges for subscripts, I'm going to notice that I am going to have multiple ammoniums, so I'm going to protect it within parentheses, put the multiplier on the outside, and I only need one carbonate, so I do not need to put that one in parentheses at all. I am asking for the subscripts for the cation. The cation is my positive ion. It's the one that comes first. That's going to be ammonium. When I'm asking for the subscript, I'm asking for how many of that particular ion I have. I have 2 ammoniums, so that is my subscript.